Hi, my name is Prajwal. I'm a PhD candidate at the BMW Group and the University of Glasgow. And on behalf of my co-authors, I'm excited to present our research titled Active Visuo-Tactile Interactive Robotic Perception for Accurate Object Pose Estimation in Dense Clutter. Consider the scenario wherein robots equipped with various sensors such as visual cameras and tactile sensors are tasked to estimate accurately the 6-degree of freedom pose of a target object which is in dense clutter. This is a common problem for robots operating in unstructured environments such as retail centers, logistic warehouses, or even households. Why is this problem challenging? Firstly, the target object may have multiple overlapping or occluding objects around it, which increases the difficulty for visual perception. Interactive perception techniques wherein purposeful physical interactions to change the state of the environment to improve perception has been proposed. Furthermore, static views from a camera may provide erroneous estimations due to occlusions, and objects may appear differently from canonical views. We propose to use active vision with multiple viewpoints autonomously selected by the robot. However, visual perception is sensitive to environmental conditions and object transparencies, wherein high fidelity tactile perception can assist in correcting and verifying the visual pose estimate. However, collecting large amounts of tactile data is time consuming. Hence, we use active approaches based on uncertainty reduction. In order to declutter the workspace, we design a declutter scene graph. From an RGB image and a depth image, the semantic segmentation and grasp affordances are estimated respectively with two networks to form the scene graph. The target object is at the root node and the edges represent the actions to perform. Using the grasp affordance output, the robot can choose to either push or grasp in order to declutter. This provides the robot the adaptability in cases where the objects are difficult to grasp and it can then resort to pushing. The process is repeated until all occluding objects are decluttered successfully. We use active vision with different viewpoints to perform pose estimation. We propose a novel translation invariant quaternion filter, which is a filter-based approach for point cloud registration. Given a source and a target point cloud, translation invariant measurements are obtained by decoupling rotation and translation. The rotation estimation is cast into a Bayesian filtering framework and estimated using a Kalman filter. The translation is then estimated in closed form given the rotation. For the next best view calculation, multiple views around the target object are sampled and the expected information gain is calculated using a probabilistic occupancy grid. The robot executes the next best view and the process is repeated until convergence. To improve the accuracy and verify the visual pose estimate, we perform active tactile-based pose estimation. We perform a proposed TIQF approach on tactile point clouds similar to the visual point cloud. We know that the tactile point cloud is highly sparse in comparison to the dense visual point cloud. The tactile acquisitions are time consuming, hence the action selection needs to be performed intelligently. To choose the next tactile action, we sample multiple possible actions and choose the one with the highest expected information gain. We see that within a few tactile acquisitions, we get a highly accurate pose estimate. We performed extensive experiments with various objects as target objects in different randomized cluttered scenarios. We also chose challenging objects such as the transparent wine glass for pose estimation. We achieved high accuracies within 1 centimeter average error for various objects with our active Visuo-Tactile approach. Our method is capable of decluttering various challenging scenarios through prehensile and non-prehensile actions. Moreover, our proposed TIQF algorithm can handle dense and sparse point clouds. Our method can also be extended to other related applications such as active SLAM, object tracking, or even other dense sparse modalities such as RGBD and LiDAR data. Thank you.